In this video, we're going to find complex roots of quadratic functions. Example 1. First, we're going to simplify a negative square root. So, for example, negative square root of 52. So, first thing I want to point out is the square root of negative 1 is I, which is an imaginary number. So let's simplify the square root of 52. So 52 we know is 2 times 26, and 26 we know is 2 times 13. So let's break down negative square root of 52. So negative square root of 52 is going to be the same thing as saying square root of 4 times square root of 13 times square root of negative 1. Square root of 4 is 2. Square root of 13 we'll leave alone. Then we have I. So officially we would write 2i square roots of 13. And we are done breaking down that radical. Example 2. We want to find the solutions of x squared minus 4x plus 5 equals 0. So recall from our last video, and when we're solving a quadratic formula, it has to be in the form of ax squared plus bx plus c equals 0. And our quadratic formula is negative b plus or minus square root b squared minus 4ac all over 2a. So let's first identify our a, b, and c. Our a is going to be positive 1. Our b is going to be negative 4. And our c is going to be positive 5. So since b is negative, it's going to be 4 plus or minus square root negative 4 squared minus 4 times 1 times 5. All this over 2 times 1. Simplify the radical. We're going to have 4 plus or minus square root negative 4 squared is 16. And 4 times 5 is going to be 20. All is over 2. So we have 4 plus or minus square root 16 minus 20 is going to be negative 4. All over 2. We can rewrite this as 4 plus or minus square root of 4 square root of negative 1 all over 2. We can just square root of 4 is 2, so 4 plus or minus 2i all over 2, because square root of negative 1 is I. So our final answer will be just 4. 4 divided 2 will be 2. So 2 plus or minus I, and we are done. And just to reiterate what this looks like, we're going to just put this in the graphing calculator just to see what the graph would look like. So we'd have x up to the second minus 4x plus 5. And as we can see, it doesn't cross the x-axis. So that's how we know that we what should have imaginary roots, and we're done solving this problem. And example 3. We're given 2x squared plus 5 equals 6x. So our first step is to set it equal to 0. So we have to subtract 6x from both sides. So we have 2x squared minus 6x plus 5 equals 0. Our a is going to be 2. Our b is going to be negative 6. And our c is going to be 5. So we have 6 plus or minus square root negative 6 squared minus 4 times 2 times 5. All this over 2 times 2. So we have 6 plus or minus square root 36. 4 times 2 is 8 minus 5 is 40, so 4 minus 40, all this over 4. So we have 6 plus or minus 36 minus 40 would be negative 4, all this over 4. So we know 6 plus or minus square root 4, square root negative 1, all over 4, which I can simplify that to be 6 plus or minus 2i, all over 4. Divide everything by 2, so we'd have 3 plus or minus I, all over 2. And we are done. If we want to see what this would look like on the graphing calculator, we can just enter this into Desmos. So we'd have 2x up to the second power minus 6x plus 5. And we can see that it does not cross the x-axis at all, so we are done solving this problem. Hopefully this helps you understand a little bit how to solve quadratics that have complex solutions.